For decades, NASA has been at the forefront of space exploration, launching telescopes that have radically changed our understanding of the universe. However, one telescope stands out among the rest, the James Webb Space Telescope, JWST. While the JWST's development was long, complex, and expensive, it is now proving that it was well worth the investment. This cutting-edge observatory has already begun unveiling the mysteries of the cosmos in ways that were previously unimaginable. From uncovering breathtaking images of distant galaxies to revealing new theories on space travel, the JWST is reshaping the future of astronomy. But one discovery in particular is stirring excitement, something called the warp bubble. But what exactly is a warp bubble, and why is this discovery so important? Let's dive into this fascinating subject. The universe is vast and filled with countless mysteries, offering an endless array of destinations that could challenge even the most curious minds. From the infinite galaxies thread across the cosmos to the enigmatic black holes that warp spacetime, to the exoplanets that might harbor life, there is no shortage of wonders to discover. Humanity's drive to explore the unknown and expand our knowledge is perhaps its most defining trait. It's a never-ending quest for answers to the big questions: what's out there beyond our solar system? Is there life elsewhere in the universe? Could there be alien civilizations at a similar level of intelligence to us? The truth is, we don't know. But what we do know is that space holds infinite possibilities if only we could reach them. Now, while some of these questions might seem like pure science fiction, advancements in space exploration have already brought us a long way. Mars, for example, is no longer just a dream, it's a target. Despite being relatively close in astronomical terms, traveling to Mars still presents incredible challenges. A trip to the Red Planet will take months, requiring astronauts to endure more than 5 months of travel through the perilous environment of deep space. But what if we dream bigger? What if we set our sights on the nearest exoplanet, Proxima b, located 4.24 light-years from Earth? The distance alone makes this journey feel like an impossibility. Let's break that down. Proxima b is approximately 25 trillion miles away, or 4.24 light-years. A light-year is roughly 5.88 trillion miles, so even traveling at the speed of light, it would take over 4 years to reach Proxima b. But with our current spacecraft, it would take thousands of years just to make the journey. Even the fastest spacecraft ever built, the Parker Solar Probe, traveling at 450,000 miles per hour, would take more than 6,600 years to get to Proxima Centauri. That's a sobering thought. But here's the exciting part: despite these overwhelming challenges, humanity's pursuit of space exploration has not slowed down. We're constantly developing new technologies to help us push beyond these barriers. One such technology that might allow us to cheat the vastness of space is the power of telescopes. While we may not be able to physically travel to distant stars yet, the telescopes we send into space help us peer across the cosmos and study galaxies and exoplanets from afar. NASA's space telescopes have always played a pivotal role in advancing our understanding of the universe. The Hubble Space Telescope, for example, has allowed astronomers to study far-away regions of the universe by orbiting Earth for decades. But the JWST takes this a step further. It is the most powerful observatory ever built, and it has already begun to rewrite our understanding of the cosmos. Not only is it capable of observing distant galaxies and nebulae, but it is also pushing the boundaries of time and space itself. With its unprecedented power, the JWST can peer further into the past than ever before, allowing astronomers to study the formation of the first stars and galaxies in the early universe, shortly after the Big Bang. In fact, the JWST is 100 times more powerful than Hubble, enabling it to see billions of years into the past, into the very origins of the universe. You may be wondering how the JWST can peer so far back in time. The answer lies in the way light travels. When we observe stars that are billions of light years away, we are actually seeing them as they were billions of years ago, since it takes that long for their light to reach us. This means that the JWST can observe light from stars and galaxies as they appeared when the universe was still young, sometimes even before galaxies had fully formed. Recently, NASA released the first stunning images captured by the JWST. These images showcase the incredible potential of this revolutionary telescope. One of the most notable sights is the Carina Nebula, a stellar nursery where stars many times the size of our Sun are born. This nebula is located about 7,600 light-years from Earth and is filled with gas and dust. Another breathtaking image is of the Stefan's Quintet, a group of 5 galaxies located about 1,000,000 light-years from Earth. 4 of these galaxies are interacting with one another, their shapes distorted by the gravitational pull of their neighbors. These images are just the beginning, and the JWST will continue to reveal even more stunning sights in the years to come. Yet, perhaps one of the most intriguing discoveries made by the JWST involves a concept that, until now, seemed confined to science fiction: the warp bubble. The warp bubble is a theoretical concept that could one day make faster-than-light travel possible. But how does it work? A warp bubble isn't quite what it seems. Rather than traveling faster than light in the traditional sense, a warp bubble works by manipulating space itself. In simple terms, a spacecraft traveling in a warp bubble isn't moving faster than the speed of light. Instead, the space in front of the spacecraft is compressed, while the space behind it is expanded. This creates a bubble that propels the spacecraft forward faster than light could normally travel through space. It's not about speeding up the spacecraft itself, but about distorting space-time to allow for faster travel. So, why is this such an important discovery? The concept of faster-than-light travel has long been a dream of scientists and science fiction enthusiasts alike. Traveling faster than light could open up a whole new realm of possibilities for space exploration. However, there's a catch: traveling faster than light normally creates problems with time dilation. This means that if you were to travel at the speed of light, time would slow down for you relative to the rest of the universe. For example, a journey that might feel like a few hours for you could take hundreds of years on Earth. Not ideal if you're hoping to maintain relationships or avoid missing out on life back home. Enter the warp bubble. The beauty of a warp bubble is that it doesn't experience this problem. Inside the bubble, time flows normally for the people aboard the spacecraft. So, even if the spacecraft is traveling faster than light, it will only feel like an hour for those on board, even if years pass for those outside the bubble. This makes the idea of faster-than-light travel much more plausible and practical. Now, let's take a look at how warp bubbles fit into the broader context of space travel. Proxima Centauri, the nearest star to Earth, is about 4.25 light-years away. That's 25 trillion miles. Traveling to this star at the speed of light would take just over 4 years, but with current spacecraft, it would take thousands of years. The Parker Solar Probe, which is currently the fastest spacecraft ever built, travels at a speed of 450,000 miles per hour. Even at that blistering pace, it would take more than 6,600 years to reach Proxima Centauri. But imagine if warp bubbles were possible. In theory, a spacecraft could travel to Proxima Centauri in just 1 month, as measured by the ship's clock, an unimaginable leap forward for space exploration. The idea of the warp bubble was first proposed by physicist Miguel Alcubierre in 1994. His theory suggested that by manipulating spacetime, it might be possible to create a bubble that could propel a spacecraft faster than light without breaking the laws of physics. However, the theory was initially met with skepticism, as it required exotic materials, such as negative mass, which had never been observed. But in an unexpected turn of events, new research is breathing life into the concept of the warp bubble. Dr. Harold White, a physicist at the Defense Advanced Research Projects Agency, DARPA, and his team have made a breakthrough discovery that could bring warp bubbles closer to reality. They were conducting an experiment involving Casimir cavities, a microscopic structure that manipulates energy, when they found something completely unexpected, evidence that negative energy could be generated. This is one of the key components necessary for creating a warp bubble. By refining Alcubierre's original design, White and his colleagues have come up with a new version of the warp drive that drastically reduces the need for exotic materials and massive amounts of energy. Their revised design, now known as the Alcubierre-White warp drive, offers hope that a functional warp drive could one day become a reality. While much more research is still needed, White believes that it's possible that we will see a small-scale warp craft in the near future, paving the way for interstellar travel. So,